Hey guys, and welcome back to a new video. In this video I have 3 big coroutine cancellation traps for you that I want to go through. Coroutines in Kotlin seem to be easy, also seem to be easy to understand. You just have some kind of coroutine suspend function which just pauses the execution while a network call is happening, while a database query is executing. And then as soon as you have the result, or as soon as that call finishes, the coroutine will just go on. Seems simple, but especially when it comes to coroutine cancellation, there are so many different complexities that most people don't even think of, which should be the topic of today's video. And I will go through 3 main mistakes where I'm pretty sure that you won't know at least 2 of them. And the little sample scenario I have created here in Android Studio is a simple screen where we can go to a photo upload screen. If we click that button, we navigate to the photo upload screen, and here you could think of the user uploading some kind of photo, clicking upload photo, maybe a file chooser opens up, and as soon as they select the file, they will also upload that photo, which of course takes a little bit of time. And in code, that looks like this. So we have an nav host, we have a home screen, which was the first screen I showed you, which in this case, the simple case just has the purpose of navigating to the photo upload screen, which is right here, photo upload screen. We have a loading indicator, which comes from a view model, and we have a lambda when we click on our button, where we also trigger the view model's upload photo function. If we take a look in our photo upload view model, it looks like this. So you can see we have a repository reference. This is really just for simplicity that I initialize it right in the view model and don't pass it in the constructor. Please always pass your dependencies in the constructor to apply proper dependency injection. But then this upload photo function gets triggered. It launches a coroutine in which it first updates our state is loading to true. It then logs something that it is now uploading the photo. It triggers the repository's upload photo function. You can see that is a suspend function. Then it updates the state to false, so we're not loading anymore, obviously. And it also prints a log that the photo update finished. The last function we need to take a look into is this upload photo function of the repository. You can see, super simplified. Imagine this would upload the photo somewhere, could be Firebase, could be your own backend, whatever, and it just simulates that delay of 5 seconds here. And as so often in mobile development, things can go wrong. So for example, if the user is not connected to the internet, if the remote server is not reachable, or if there is some other kind of error, then this upload photo function, which in this case is just a delay, would throw an exception. And we of course want to catch that here in the repository, so we have a catch block and we print the stack trace. Seems correct, doesn't it? No, there is actually an issue with this code. Maybe you already know it because I talked about that in an earlier video already, but I'm pretty sure that most of you won't be aware of what the issue here is. And I also noticed that in my 10-week Android mentorship program, where I review a lot of people's code. Until today, I don't think it ever happened that someone did this correct right away without needing a comment from me before. If we launch the app here and take a look, and especially take a look here in the view model, if we launch a coroutine in view model scope, then that means all the coroutines launched in view model scope will of course also live as long as the view model does. Then that means when the view model is destroyed, that view model scope and all its coroutines will also be destroyed, or will be cancelled in this case. That is how we would call it for coroutines. And if we now think about when a view model would be destroyed, that would be when it is popped from the backstack, so when the corresponding backstack entry or the corresponding screen the view model is tied to is popped from the backstack, then all the coroutines launched in view model scope will also be cancelled. So far, so good. Let's take a look in our app, and especially take a look in logcat to see these 2 logs here. So first, if we click this button, we should expect the log uploading photo. And if the photo upload is done, we should see photo update finished. You can see I already added a tag here. And if we go to our app, click go to photo upload, click upload photo, then you can see it takes 5 seconds. We see uploading photo. And after that was finished, the loading indicator disappears and it says photo update finished. So far, so good. But what happens if we click upload photo and then go back? You can see it still prints photo update finished. But usually what we would expect is that if this coroutine is cancelled, because the view model is destroyed when we navigate back. And it is cancelled at this point where it's currently stuck at the upload photo function, where it's currently uploading the photo. Then we don't expect that it still executes the code afterwards, right? No, if this coroutine is cancelled here, then we expect that it is really cancelled there and does not execute any further code, which could lead to some kind of inconsistent application state. But that is exactly what's happening here. And now let me tell you why. The issue lies in our profile repository, because the way coroutine cancellation works is if a coroutine is cancelled, which would be the case here in case of viewModel scope when we navigate back, because then the screen is popped from the backstack and therefore also the viewModel tied to that screen will be popped from the backstack. As soon as that is the case, the currently suspending function will throw a cancellation exception. And what is the currently suspending function in this case? Well, it's of course repository.uploadPhoto. If we take a look in there, then the currently suspending function is the delay function. So this function will throw a cancellation exception as soon as we navigate back, because viewModel scope is cancelled in that case. But what happens here is, because of this try and catch block, this cancellation exception that is thrown by this delay function will be caught here. And that is also what we should be able to see in Logcat if we search for cancellation exception. You can see here it actually prints this job cancellation exception, job was cancelled, because this function threw that exception and now it was printed. But the issue with this approach is that if this cancellation exception is actually caught, the parent coroutine scope won't be notified about that cancellation. So it won't properly be propagated up the coroutine scopes. And you can just destroy your whole structured concurrency that way. And the parent coroutine scope in this case is our viewModel scope.launch coroutine here. So this won't properly know about the cancellation and therefore it will simply go on with its code even though the coroutine was cancelled in this upload photo function. How do we now deal with it? Well, dealing with that is super easy. And that is by going to our profile repository and rethrowing that cancellation exception only if it's a cancellation exception, of course. So we need to check here if E is a cancellation exception, and then we throw E again. So that way we can still catch exceptions that could, of course, occur from uploading a photo. So these could, of course, also be I/O exceptions or some kind of HTTP exceptions or so. But if it's a cancellation exception, we want to rethrow it so the parent scope will also know about that cancellation exception. So if we now relaunch this, take a look and Logcat again, search for photo upload, viewModel, let's clear this here. Take a look in our app, go to photo upload, click upload photo, we can see our log. We now go back and cancel the coroutine. Now it does not print this photo update finished anymore because the coroutine was properly cancelled. And in this case, this launch block or this coroutine here would also know about the cancellation, so it also knows that it should not execute any further code after that cancellation happened. And depending on what you're doing, this can really lead to inconsistent application states if you just execute code afterwards, where you really assume that this is only executed if the photo upload at least finished, no matter if it succeeded or failed. But if the whole photo upload was cancelled, then you usually don't want to execute the code afterwards. So therefore, always, if you have a try and catch block inside of a suspend function and you catch general exceptions like here, then you need this line of code. An alternative to this is, of course, that you just catch specific exceptions. So if you just have I/O exception here, for example, and then you have another catch block for, I don't know, HTTP exception. Let's say we use retrofit here. Then that is of course okay, because these catch blocks do not include cancellation exceptions. But in that case, you need to know all the possible exceptions you might want to catch. Very often, we just want to catch general exceptions. That is fine, as long as we rethrow cancellation exceptions if we are inside of a suspend function and we catch general exceptions. By the way, you don't need to be inside of a suspend function, but rather inside of a coroutine. So if you would have this try and catch block and you would execute it directly here, this would of course be the same. So if you have the try catch here, you catch general exceptions, you would of course also need to rethrow these cancellation exceptions in that case. But typically, the strong hint is that you have a suspend function and you have a general catch block. Okay, let's get to mistake or trap number 2. And for that, we want to take a look in this package. We just have a little note table here in room, entity annotated, we have primary key, just normal stuff. And let's say we want to build an offline first step. In that case, we somehow need to keep track of what is already synchronized with the backend and what isn't. So in this case, we could have an async boolean here, which would be false initially, and as soon as we sync that node, we update that to true. So maybe if you're not familiar with offline first development, offline first apps, those are just apps that should also have the same user experience, or at least the best possible user experience in offline mode. And if the user is in offline mode, maybe has airplane mode enabled and saves a node locally in the app, then at that point, we can of course not sync that with the backend yet. But since we still want to guarantee that best possible user experience, and we want the user to save that node, because just saving a node isn't really bound to an internet connection, we need to save it locally on the device first, and then try to sync it later when the user is connected to the internet. And to do that, it's just very common that we have something like an async boolean here, or we have a separate table where we store references to those nodes that aren't synced yet, something in that direction. And then we just have a node API, which would be the backend here, to just push a node to the backend. And we have a node DAO from Room, where we would just upsert the node locally. Just a super simple sample setup here. The magic happens in our offline first repository, which now accesses both these data sources, so our DAO and our API. And if we then take a look at our save node function, you can see this time we do everything correctly here by rethrowing the cancellation exception. So that is not the issue anymore with this second mistake. But if we take a look in this try and catch block, first of all, we want to upsert that node. So we want to insert it into our database and update it if it already exists. Initially, the async boolean of our node is of course false, because at this point, we don't yet know if this API call will succeed, so we assume that it's not synchronized yet. However, even if this API call fails, we still want to be sure that the node is already saved locally, so the user can still access it. So far, so good. So if we then save the node here in our API, then this function might either succeed and go on with this line of code, or it might fail, throw an exception, and then we will just break out of this function. That would be okay, because here in this line, we update is sync to true, because if the try and catch block reaches this point, we know that the API call must have succeeded, because otherwise it would have thrown an exception. So in this case, we can update the async boolean to true. And if it fails, then the async boolean will remain false. So another function could just regularly fetch all the nodes that aren't synced yet and try to sync it with the backend when internet is back, for example, in a work manager worker. So does that look good? No, there is actually a big issue with this code. Because always when you have such a code, you need to think of cancellation. Your coroutine where this suspend function is running in could be cancelled at any point. It could be cancelled here in between after you already upserted the node and did not yet initiate the API request. It could also be cancelled after you made the API request and did not upsert the node with isSync being equal to true yet. And if we take that example, so let's say your API saved the node, that was successful, so the node is saved remotely, but then the user maybe hits the back button, goes back, view model scope is again cleared, view model scope coroutines are cancelled, and at this point, right in between saving a node for the API and upserting the node locally with isSync being equal to true, right in between, this suspend function and the coroutine would be cancelled. So the last line would not be executed anymore, even though the node was saved on the API. And then you effectively have an inconsistent state, because the node was already synchronized with the backend, but locally you still think it's not synchronized yet, because this line was never executed and it did never update the node in the local database. In this case, it will probably not be a huge problem, because if the app still thinks that the node is not synced yet, then we'll just try to sync it later and it will just save the node again. But depending on how you handle this scenario, you could really run into serious issues. So always, if you have multiple suspending calls inside of such a suspend function, think about what would really happen if this coroutine would be cancelled in between. So how would we now deal with this? Let's take this example again, that that we would not update the database locally, that the node was synced if it was cancelled right in between these two calls. Then we have different possibilities here. So very often, if you have multiple database calls in a row, then this could be a hint that you should better use a transaction. So transaction is just a database mechanism that executes multiple database calls, but will only absolutely apply them all if they all succeed. If there is one call that fails, none of them will be applied. So you could, of course, just take this code, put it in a transaction, and if something fails in that code, such as a cancellation exception is thrown, then the change won't just be applied. In this case, this is not really what we want, because in any case, we want to upsert the node. We want to have it locally. So here we just need a different solution. And that is by using with context non-cancelable. We can use that to wrap this around our call which we want to execute in any case. So even though the coroutine would be cancelled at this point here, thanks to this non-cancelable context, we would not cancel the coroutine and would basically make sure that this line will always be executed. Even though we might navigate back, the view model scope coroutine might be cancelled, this function here will be executed because of this non-cancelable block. So now we can go through these scenarios again to check if it's now safe with this function. First of all, if the coroutine would be cancelled while uploading the node here, would not be an issue. Then the user would just navigate back, or there would be something where the user knows, okay, I did not really save the node. And it's also very unlikely because that's a very fast call. If we then try to sync that node with the API and push it to the API, to the remote database, then what happens if this call is cancelled here at this point? Then, well, the code would again jump into this catch block since the cancellation exception would be thrown. In that case, everything is in sync because we still have the node in our local database with isSync being equal to false. So that is correct. The API can get the node later when internet is back or when the coroutine was not cancelled. And if it's cancelled at this piece of code here, then that's also not an issue because we just dealt with that with this non-cancelable block. If you really feel like you're making a lot of these mistakes because all that is new to you, it's really easy to actually step into these traps. And I also did that quite often. Even if you know about these, it quickly happens that you step into these traps. But if you feel like you need someone else to look over your code, then definitely check out my 10-week Android mentorship program, which you can find by clicking the first link in this video's description, because in that program, we will build a real industry production-ready app over the course of 10 weeks, also an offline first app with the databases, APIs, custom UI, authentication, scheduling notifications, photo upload, work manager workers, all that stuff that you just need so often. So if you just want to build such an app and want to get code reviews from an experienced Android developer, then apply by using the link down below. But now let's get to the last cancellation mistake. And for that, I want to go back to our photo upload view model and extend that with a little read files function. It's actually just a single read file function. File reader is a class that we already have in our project. This one here. And if we take a look in the file reader, first of all, to understand what that does, then it's a very similar function as I previously showed in a previous video, which was all about switching the coroutine dispatcher here. But then the rest is comparable because all this function really does is it reads a file from our assets folder. You can see it opens an input stream and then reads the bytes and returns the result as a byte array. And then finally, it also prints the file size it just read. With context block, we just make sure that it's executed on the right dispatcher, that we can also really block the suspend function while we are reading these files. And then in our photo upload view model, where we make use of that file reader, you can see here, view model scope.launch, we launch a child coroutine, where we just initialize such a file reader and reread a file from our assets. In this case, just a 100 megabytes test file, which of course takes a little moment. And then after 3 milliseconds, we cancel the job. So reading a file is very fast, so I just needed a very short delay here. But this could, of course, also be navigating back if that's a longer action. So we just want to make sure that we initiate reading that file, but we don't finish it because in 3 milliseconds, you can't read a 100 megabyte file. So we cancel it right afterwards. And we also print that reading the file was canceled. And in our file reader, we print the file size if it was fully read. So what's the issue with this code? Let's take a look at our main activity to execute this and see what happens by just, let's just replace this lambda here with viewModel.readFile, pass in our application context, launch this app, and then especially take a look in Logcat. And we want to search for read file. Take a look here, go to photo upload screen, click upload photo. Then you can see we just got an out-of-memory error that was not planned. Maybe I should execute that on a device with a little bit more RAM. Maybe we can also try this again by relaunching the app, but maybe this does not change anything. Clicking this, upload photo. No, okay, it seems like it still crashes, which is of course obvious because we're trying to read a 100 megabytes file here into memory right here, which definitely isn't ideal, so please don't read a large file like this. But let me try to find a little bit smaller file with which I still hope I can show you the issue with this. All right, I'm back with a 60 megabytes file, and now it seems to work, at least in my single try. We want to go to photo upload to see what the issue with this code now is. Click upload photo, and you can see it prints read file was cancelled, but it also read the file with a size of roughly 60 megabytes. So even though we canceled the coroutine before, it still read the full file. And what we expect to happen is, if we cancel it while reading the file, it should also stop reading the file at that point of cancellation. But that doesn't seem to be happening here. And that is probably the most common example you get when people speak about how hard coroutine cancellation is. That is a very common problem, which you maybe already knew about, but I still see so many people not fully understand what this really means, that coroutines and coroutine cancellation should be cooperative. So if you take a blocking but not suspending function and you want to transform that into a suspending one, which is exactly what we do here. So we have a blocking function, which is this read bytes function, but that is not a suspend function. You can see there is not this little arrow here. And we want to transform that into a suspend function so that it blocks the coroutine while reading the bytes. Then we need to do that with context. But we also need to make cancellation cooperative here. So we actively need to check for cancellation while executing this read file from assets function. And that right now does not happen. Here's no place where we can actually check for cancellation. So how do we now do this? Well, let me show some different code here and paste this. Looks more complex, is more complex, so we basically now use a byte array output stream. We use a buffer here, which also gets rid of these cancellation exceptions, since we don't read the whole file into memory anymore, or at least not all at once. And then we go inside of a while loop, and we just use this read function. So not this read bytes function anymore, which reads the whole file into a single bytes array. No, we actually use this buffer, and we just loop over this step by step until we read the whole file. And now here is where the magic happens. Because we do this step by step with this approach now, we can call ensure active, which comes from this coroutine scope here, which, well, ensures that the coroutine is still active. If not, it will break out of this coroutine here in this case. So if the coroutine was cancelled and maybe half the file was read, then this will actually make sure that the while loop is not further executed and we won't read the rest of the file after cancellation. So now let's take a look at how this behaves again. Take a look at logcat. Go to photo upload, upload photo, and you can see read file was cancelled, but this time it does not print that it read the file with a size of 60 megabytes. Because it was cancelled before, it might have read maybe half the file, but after cancelling, we expect that it actually really cancels reading the file. And that is always what you need to make sure if you are transforming a non-suspending blocking function. Like again, reading a file here, there is no suspend function inside of this piece of code. And you want to transform that into a suspending function, because with suspending functions, we assume that if we cancel it, it also really cancels the code inside of it, and that code won't really go on. But in order to achieve that behavior, you really have to make sure that you use ensure active. You can also use if is active, so that is the same, and then execute some piece of code, or if it's not active, you break out of the code or so. But either that or ensure active needs to be used if you really want to make this behave correctly inside of coroutines. So if there were some mistakes in this video which you did not know about and which you maybe already did by yourself, I'm pretty sure about that, then let us know below. And also if you have more concepts about coroutines which you find hard to grasp, which maybe go beyond what you learn typically online about coroutines, then I'm very happy to make a video about it. But just let me know what that should be, and I'll definitely consider it. Thanks so much for watching. As I said, if you want to work with me together very closely, apply for my mentorship down below. I wish you an amazing rest of your week. See you back in the next video. Bye-bye.